In this video, we're going to review the idea of the Cartesian coordinate system. It is also called the rectangular coordinate system because it is based off of rectangles. The reason why it's called the Cartesian coordinate system is it was named after the person who kind of came up with it, Rene Descartes. But regardless, it's a system you've almost certainly seen in previous math courses. We just want to make sure we're fully aware of how it works before we get into using it in this class. So in the Cartesian coordinate system, you have a point called the origin. That's this point in the middle here. You have two axes that go through this point. You have the horizontal axis, also called the x-axis, and you have the vertical axis, also called the y-axis. And once you've set this up, you can pick any point anywhere you want, and you could write down numbers that represent it, saying it takes 3 steps to the right of the origin, 4 steps up from there, so 3 and 4, and this point would be called 3, 4. Always the horizontal distance is placed first and the vertical distance second. And doing this now allows us to give a name in terms of 2 numbers to any single point. And once we've done that, we can do calculations to answer geometrical questions. It was a very important concept, being able to unite algebra and geometry, and it really helped us improve a lot of mathematics and delve into more complicated topics. One thing to note is that if you're going left or down, so in this case I went 3 left and 2 down, the coordinates are going to be negative. So right is positive, up is positive, left is negative, and down is negative. Now if you have 2 points, let's call them x1, y1, and x2, y2, just 2 random points, whatever numbers they are, we can create a formula that tells us how far away those 2 points are, the distance between them. And you get this by subtracting the x coordinates, squaring it, then subtracting the y coordinates, squaring that, adding up the 2 squares, and then square rooting. And it turns out this is really just the Pythagorean theorem. So the idea is, how far did you move to the right? That's going to be x2 minus x1. How far did you move up? It's going to be y2 minus y1, or at least the absolute value of those numbers. And if those are your 2 sides of this right triangle, you can find the distance here by using Pythagorean theorem, a squared plus b squared equals c squared, and you're going to get exactly this distance formula. Now we aren't going to be using the distance formula all that often in this class, but it is a useful tool to have in the times that you can use it. More importantly, we're going to use the distance formula to figure out the equation of a circle. So how can we describe a circle? So you have a center for the circle, which we're going to call that h, k. And a circle then says, go out a distance of r and find all points, and that's a really horribly drawn circle, but that's okay. Find all points that are r units away from that center, and that's going to be a circle. So that means we want all the points where the distance is r. So that means the distance formula from a point away from the center is r, and the way we normally write it is we square both sides. X minus h squared plus y minus k squared equals r squared. And we are definitely going to be dealing with circles in this class, so it's a good idea to remember what the formula for a circle is. And the most important of all the circles we're going to deal with is called the unit circle. And this unit circle is when you have a center at the origin and you have a radius of 1. This is the unit circle, and we're going to be using this probably 100 times or more in this class. I mean, honestly, 100 is pretty a low estimate here. So if we look at this formula and we have a center of 0, 0, and a distance of 1, we get the equation x squared plus y squared is 1. And you definitely want to know the equation for the unit circle. Okay, so this is a quick rundown of things that we need from Cartesian coordinates. And we're going to move on to other topics now.